Oh, exams.
Yeah, but the assessment is too much for us.
What do you mean the assessment?
All the subjects. We have essay, chemistry.
Oh, the assessments are too much, I know. It's a lot of work, yeah. Yeah. But look, it'll be over soon.
But we have no time to review the class though.
We'll do revision in class.
Yeah, but
I understand. It's difficult. There's a lot of work to do. I know. It's difficult. It's stressful too. But like Summer said, life is difficult. Right? You should be more like Summer. Don't worry so much. Right? Are you? You don't look worried. Worried. Okay. All right. The health here. So, this last lesson is very, very easy. Very, very easy, which is good news for you. So just to recap, do you remember we had mean, average, yeah? And then we also had this thing called standard deviation. Mu and sigma. Do you remember that? Yeah? So we could draw a picture, for example. Maybe this is some people's height. Right? So, for example, maybe this is 170 centimeters, and then the sigma is 5 centimeters. What can you say about the heights? Is everybody 170?
No.
Go. Average is 170. What about the 5? What does the 5 mean?
It's
Yeah. So you could say most, but not everyone, most people are between 165 and 175. Yes? Yeah? Yeah. And we also learned last week how to calculate percentage. So if I said to you, how many people are between 160 and 170, you know that you have to calculate this area. And we learned how to do that last week by using Z. We learned this last week. Now what we're looking at today is important for you, for physics and for chemistry. It's something called a confidence interval. So here's the problem. You're doing an experiment and you have to measure something. So this is your machine. And you get your data. And maybe, for example, you have 10 points. You know, maybe you have like maybe you're measuring, I don't know, maybe you're measuring the height of something. So maybe you measure 1.01, 1, 1.01, 1, 1, 1.011, 0.999, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, what do you use for the height? These are in meters.
Add it together.
Yeah.
And over 10.
Over 10. What's that called, Ben? That's called the average. Is that going to be the right answer, though?
No.
No. It'll be close to the right answer. Yeah. But you understand that you have a plus minus uncertainty here.
Yeah.
And what we want to learn today calculate this. Now, it's actually not so difficult to calculate. What you do is you say that the true value, which we'll call mu, is going to be between two numbers. Oh, and Ben, or maybe, I know, Gail, you know this one. What letter do we use for the average from the data?
Big A.
No, that's what you use in China.
So,
Yeah, we'll use something like a H with a line on top, or X with a line on top. Okay, so the true value will be the average plus a number, and an average minus the number. And the formula is this. You use 1.96 sigma, and you get the sigma from here. Now, the good news is, in the exam, you don't have to calculate the sigma. They just give it to you. So, yeah, they might say something like sigma is 0.099, or, you know, whatever. They give it to you. This is given. Yeah, Ben?
n square.
Over square root n. And here n is 10. Okay, and this is 1.96 sigma over root n. Okay, so by using this formula, you can calculate what you might call limits for the possible true answer. You think the true answer should be more than this, but less than this.
So the uncertainty is like 1.96 sigma over rho.
Yeah, correct. This is like UX, the uncertainty.
One.
Huh?
One.
Ah!
Okay.
Yeah, no, the problem is, Ben, what happened was,
You just give the.
yeah, no, but just let me explain, because it's a good question.
No,
What
I don't
happened-
think so. I don't think.
No, I won't explain, I'll just tell you why it's like this. What happened was, the person who made this syllabus, they wanted students to study this. But to study this fully, you need to do all those pages I skipped. Remember I skipped pages?
1.96 is constant.
Yeah. Now why 1.96? The reason for the 1.96 has to do with the tables for the bell. I want to go into more detail, but the problem is the chapter is not on the course. It's deleted. So it means you must trust that this is right.
Delete is cancel.
Cancelled, yeah. So I can't give you a good reason.
Okay.
But Ben, you're right, it's just a constant. Okay?
How
Now-
to write that down?
Just before we go on, tell me this. For example, what happens if the n gets bigger? Does this get bigger or smaller?
Smaller.
Smaller, if the n gets bigger, right?
Yeah.
Doesn't that make sense? You know, if you have 1,000 measurements, isn't that better than 10 measurements?
Yeah.
Yeah? And if all these measurements are nearly the same, is that good or bad? That's good.
Good.
What happens to this if they're all nearly the same? Is this bigger or smaller?
Smaller.
Smaller. If that is smaller, then what about this? Smaller. Can you see? I'm trying to say the formula makes sense. You know, it seems right. Okay. Some books don't write 1.96. Whoops, they just write 2 because it's just easier. You know.
9.81.
Huh?
Like 9.81.
Yeah, 10. It's just easier. And some books don't even use 1.96. Yeah. So this is the only formula for today's lesson. And I think this formula is in the formula book.
Oh, nice.
It's So it's a small little lesson to finish. Yeah. So can you write this down, and then I'll let you try a question.
Will be the table given again?
Say again?
Will be the table given again, this table?
Oh, of course.
Because I lost it.
Borrow mine one. You don't need it today, but you can keep it. I don't need it. I have all this up here.
R4?
No, of course not. Come on.
Confidence interview.
Yeah.
I think we kind of got this error before in the lab report.
Correct. Yeah. And to be more precise with the title. Oh goodness, my pen's stuck. To be more precise with the title, this is called a 95% confidence interval. So what you're saying is here, for goodness sake, what you're saying here is we are 95% sure that the true value will be between these two. So Ben, the reason for the 1.96 is so that we can be 95% sure that this is right. If you want to be more sure, then this will be bigger.
Yeah, the same as what at high school was learned.
Yeah, okay, good.
Yeah, 95% sure.
Yeah.
We need to write down this.
Yeah. Did you write this down somewhere?
So we are 95% sure which we read. This.
Did you write this?
Yes.
Did you write the title?
Yes.
Did you write this?
No.
Please write it.
If it is.
Good. I want to see.
I mean, this lesson is.
That's all you need to know for this lesson. So I just want you to practice one to see if you get it right, okay? I want you all just to do number 6 and tell me the answer. So, we'll read it together. The lifespan of 10 batteries. Now look up here. You have a few letters. You have average, standard deviation, so X, sigma, true answer, and N. Okay, so the first thing, the sample of 10 batteries. So what is the 10 here? N. The sample mean of the 10 batteries is 97.164.
Mu?
No, that's X bar. That's the X. And the sample standard deviation is 5.2534. What's that? The sigma. The sigma.
Oh.
Calculate the confidence interval. By the way, Gao, we can never know this because we would need to have all the data to know the true value. So this is, Gao, this is always in the middle. Yeah. Right, give me the confidence interval. Go calculate.
True. What do you want?
The two values. Yeah. So, Gao, I need you to tell me the true average is between what two values?
Okay.
Oh, and you can give me the answer to one decimal place.
Was 93.9 to 1.
Wait, hang on. 93.9
Yes,
up to...
100.4.
Okay,
So
correct.
we keep. So what's the uncertainty we keep after the point 3?
Oh, usually in the exam it's 3 significant figures. So you go 1, 2, 3, and then 1, 2, 3, and then you wouldn't write this.
So it's no matter what's the uncertainty we keep like.
Oh, I know. Yeah, in physics. Yeah, you learned this in physics. Yeah. In the maths, no, they don't care about that. I understand what you're saying. So, I'll tell you what. I'll just give you one question to do. If you get this right, then you can just go, because there's short lesson. Now, wait, don't be happy all of a sudden, because the next maths class and the next physics class, we're going to work on exam questions. So it's going to be lots of working now in the next class.
That's great.
Is it?
Yeah, that's great.
Okay, so just do question 10. When you're finished question 10, you can go have your second lunch.
No, that's the only meal we had.
Oh, so sad.
It's great.
So do you understand what's happening in number 10?
The
Yeah.
one.
I'm giving you the answer.
And find
Find the average and the standard deviation.
So it's X bar and sigma.
Yeah, I want those two.
The first one is the average.
That's what I want.
No, you give
Oh no, that's the answer. What I gave you, Ben, was these two numbers, the lower and the upper.
oh.
You understand? I think this was an exam question, by the way.
Three significant figures.
Yeah, give me 3 significant figures. Three SF, please.
I got sigma.
What did you get?
0.646.
646? No.
No.
2, 1, the X
Yep.
line is 383.
383.
Yeah.
Oh, sorry, Gal. Sorry. You're right. Sorry. What did you say it was? 0.646.
46.
And what did you say here, Summer?
383.
The x, what's the x?
3 is 3.
No, I don't think so.
2, 5, 6.
256. Correct, Ben. What happened, Summer? You got this one right.
No.
Ah, okay. Ben and Gao got them right.
It's just maximum minus minimum and over 2.
Smart. Smart.
And we get the uncertainty.
Yeah. And then, yeah.
Calculate.
Yeah, so yeah, it's you're saying it's easy to get this one first. You should get this one first and then get this one second.
The first it's okay.
It's okay, whatever. Oh, yeah. I see what you're saying. Yeah, this one is easiest to get first, isn't it?
Yeah.
Because you can just say it's the lower plus the upper
Yeah.
over 2, because it's always going to be in the middle.
Yeah.
Yeah, very good, yeah. And then you can do upper minus lower over 2 over 1.96 over
and 10
and multiply square root
root
10. Yeah, I like it. Good idea. Did you do it the same way?
No, I kinetic the equation.
Made 2 equations
Minus.
and minus simultaneous equations. Yeah,
10.
not so difficult.
But you say
No, but I just want to tell you. Friday. Okay, so from now on we'll be doing exam questions.
Yeah.
So you will need to have Moodle.
we have
You can use Moodle on your phone, or if you want to bring your laptop, that's fine too. But I do need you to bring your laptop on Friday.
we have
Physics
How
and Fred.
It doesn't matter.
how
Because-
about tomorrow?
No, this is my plan now. This is what I'm going to do from now on. I don't care what the timetable says, okay? We'll do physics, maths, in 1 hour. I don't care what the timetable says. So tomorrow, we'll do a physics for 1 hour. Then in the next hour, maths. Then physics, maths, okay?
So we all need just Moodle.
Just need Moodle.
Oh.
Yeah. Except on Friday. On Friday, I want to make one of the physics classes about the lab. So how many classes do we have on Friday?
2.
Okay, so one of them will be about the lab report, and the other one will be about maths.
Okay.
Do you understand? Yeah. So you don't have to bring this book. You don't have to, but maybe you have some notes in it that is useful. It's up to you, okay? All right. What have you got next? How many hours?
2
True.
hours.
2 hour.
2 hours and 2 chemistry.
Oh.
Lunch break?
1.
1.5.
We got lunch now? No, I mean like you're free now.
Yeah.
And in 1 hour you'll have EAP.
Yes.
Oh, nice.
Nice.
You have nearly 80 minutes for lunch.
It's terrible this afternoon. EAP and chemistry.
EAP is easy.
For you.
Not for me, I promise, Ben. Maths is easy for me. EAP is not.
And when is the exact time where we got the final result?
I have no idea.
Just during August.
Yeah, I think so. You should talk to your tutor. Who's your tutor? Neil? Colin?
But because we don't, in China we can't receive the Gmail.
Oh yeah, Chinese government. You can't receive Gmail.
Yeah, no.
Why?
We can't use Gmail.
We can't.
No, you can't receive any letter in China from Gmail.
Can you? Yeah, VPN.
Yes.
The one I use, and Joan, your other maths teacher, Joan, we both use this company. We like it. It's cheap, it's good, lots of options, IBVPN.
Fast.
Fast, yeah.
Oh.
Because I use it for videos.
Can use in China?
I think so, because I think it has a Chinese option.
Oh.
You can pick like, you know, if you're in China, you can press this button.
Okay.
Yeah.
So,
See ya. Now there's two options. You can buy the normal package,
Yeah.
which lets you have one connection,
Yeah.
like on your phone or your laptop, but you can't use them at the same time.
Yeah.
What I do is I buy their like special package, which lets me have 5 connections. So I can use it, my wife can use it, we can have it on the TV, can have it, you know, on my tablet.
Why you need VPN?
Why?
Yeah.
You know, like if you want to watch something that's in the UK,
Oh yeah. Yeah.
it will say you can't watch this only if you live in the UK.
Yeah.
You know.
Oh, I know that.
Or sometimes my wife's American, so maybe she wants to watch American TV. Things like this.
I live in China.
And you live in China, so you can't do anything in China.
And some of my classmates they build themselves the internet.